Hello everyone, welcome to this video by DataSense. I welcome you all to this new full-fledged course on exploratory data analysis using Python by DataSense. In our previous course, we discussed about various Python data structures and how to use them for various use cases. In this particular course, we are moving towards the practical aspect of Python, where we will take a particular live data set and see what all type of analysis can be done over it. So, as discussed in the previous course that yes, data structure and algorithms are the main part in interviews. But once you have done that, once you come to the real world, you will be expected to do a lot of analysis, and it is very important to know what all kind of analysis, what all kinds of libraries are present in Python which you can leverage to automate your work, be it setting up data engineering pipeline, be it doing some data analysis, be it doing some model prediction, be it creating any MLOps pipeline. So all that is dependent on technically on Python, because as we know, Python is the central language to all these particular tasks. So this course, as I mentioned again, it is more on the practical task. So let's move ahead. At the first of this course, we will discuss about what all data roles are present in the industry. You might have heard data engineer, BI analyst, machine learning engineer, database architect, or data scientist. Where do all these lie in on us if I have to plot them in a single pipeline? Once we have plotted them, we will see which part of that pipeline does this course caters to. Okay, so let's, without wasting time, let's directly switch to discussing that particular pipeline. Okay, so discuss this pipeline. Let us go from the scratch, that how data is collected. Okay, for example, let us say there are three scenarios. First is, let's say you order a food online, or you are serving any website, or suppose you went to a shop. For example, you went to a Walmart, or you went to a Best Buy, or any such particular store where you you swipe your card in a POS machine. These are the major three sources of data. Otherwise, data is collected in multiple manners as well. But the whole process, the automation process, if I see, major data is collected in this format. So this all data, actually, this is called OLTP. Okay. This is called OLTP data. It technically means that you are, so online transaction processing. So it means that data is collected in real time. So this data is not in the form of the tabular structure data that you see most of the time. This data is generally in a JSON format. A JSON format, you might, you all know, it is a kind of dictionary where example, you have this kind of thing, then you have key, then you have value. Okay, so then you have again another key, again value, another key, again value. So this type of data is present. Now, how this data is collected from real time? This is collected through various methods called as APIs. Okay, and they are real, so they are clickstream data. So whatever data you collect through website, it is called clickstream data. Okay, and there are multiple other sources as well. For example, so this is streaming data. You say, for example, let's say you're collecting from food ordering, where which kind of restaurant did you order, what food did you order, and like all those things, what was the time of your order. So all this data is collected from a real time servers which are present at various steps. Okay, so as I mentioned, they are not the real, they're not the ideal data that you see in your tabular structure. So this data set is collected. How this is collected? Now this is collected through various systems. So if you know, this is called Apache Kafka. So there is a called Apache Kafka. This is used to collect real-time data. And similarly, there are some big queries which run, and BigQuery, and let's say there are some Python and SQL scripts which run and collect these data in a real-time format. Now this data is called a raw data. You cannot process them. Okay, so this particular task is generally done by data engineers. So data engineers develop methods so that they can get and arrange these particular data. They can collect this accurate data, because for example, let's say whenever you use any mobile app, you see the rate instantly, and suppose you see an Uber search price, you see all that instantly. So in real time, data is being processed and it is being like whatever analysis is done, whatever model prediction is done, everything is done like in real time. Okay, so these all happen because of the settings that are done by data engineers. So let us say this raw data is collected now. Your company has multiple trucks, for example. Okay, and so let's say this was truck 1, there was truck 2, there was truck 3. Okay, let's say this this is symbolically representing collecting the raw data from the from whatever methods are there. Now what will happen, just like okay, you have got the raw data. Now you want to convert this raw data so that you can use it for your analytical purpose or your like models or anything. And as I told, data cannot be directly used on the format like it is present here. So what you do, first of all, you take all this data and you have to store in a big thing called data warehouse. Okay, so either it is a data warehouse or it is a data lake. So data warehouse, it can be a data warehouse as I mentioned, or it can be a data lake. Okay, now what is the difference between data warehouse and data lake? Let's talk about that first of all. So as I mentioned, that data can be structured or unstructured. So what is a structured data set? For example, if it is present in a tabular data, that is, it is a SQL data. So it is a structured data set that it has a row and column. But what if data is like audio file, or let's say it's a video file, or it's a JSON data, or it's an XML file, those kind of file. So they cannot be stored in a data warehouse. So what is the difference between a data warehouse and a data lake is that data warehouse can only take structured data. Okay, only. So what if you have used your SQL server, Snowflake or anything, you see data warehousing. So this only takes structured data, that is SQL database. Okay, so where data is present in a tabular format. Okay, there can be other formats as well. For example, there's an Excel, there's a CSV file. So whatever thing is there where data is in a structured format, data warehouse takes that. Data lake takes both. So it takes structured as well and it takes unstructured as well. As I mentioned, 60 to 70% of data is unstructured in real time. Okay, although in your life you would have mainly dealt with structured data only, and that is because some data engineer would have converted and you are seeing the analytical data, right? But in real time data, you see most of the data is present unstructured, and that is the major task in ahead of data engineers, that how do they convert them. So as I mentioned, you get the raw data from various sources. Now your job is to dump them either in data warehouse or data lake. For example, let's say I talk about Amazon example, right? Amazon takes the order from different cases, different places, and it stores in your cities. So there in city there are multiple warehouses, right, where Amazon stores the product, and from those warehouses they have their special delivery mechanism which deliver close to your house, right? So what happens that in a city, let's say there's a city, there are multiple warehouses, like there's a warehouse here, there's a warehouse here, there's a warehouse here. What will happen that whichever warehouse is closer to your house, your item will be shipped to that particular warehouse, and from there it will be delivered to your address. So this is how things are done, that we take the raw data, we store them in data warehouse or data lakes, and from there, depending upon the use case, you utilize them. Now how this process is done, okay, that is the key component. This is also done by data engineers. Okay, this part is also done by data engineers. So what all data engineers do? First was they collect the raw data, and the second is they transform it or basically load them into data warehouse. So their first job is to collect raw data, and the second job is to put them, so basically store in data warehouses or data warehouses or data lakes. Okay, and what are these? So what are these data warehouses or data lakes? So they can be SQL servers. Okay, they can be NoSQL servers. What are NoSQL servers? It is MongoDB, Cassandra, or it can be like Couchbase, there are multiple NoSQL databases, or it can be SQL. For example, your SQL Server, your SQLite, or Snowflake. There are multiple things. And then there is cloud. What all comes in cloud? In cloud comes your GCP, AWS. Okay, all that thing comes into cloud. So let's discuss a little bit more about this particular part, where we see what all types of storage are there. So what did we see so far? That we have a raw data present here, okay, and we have to technically load them to various data sources. So like either data warehouses or data lakes. Okay, now what are these? So how these things are done? Because see, data can be very much, I mean, for example, they can be of few GBs, for example 10 to 20 GBs, as well, or they can scale up to thousands of GBs. So how do you ensure that, okay, you can run a simple SQL script here, or you can store in a normal warehouse like this kind of data, but this kind of data you cannot store in a normal database in a normal format, right? So this is called big data, that whenever your storage is very large, right? So there is no specific number, but I think beyond hundreds of GBs, it is generally considered big data. So you have to process this data as well, and you have to process this type of data as well. So this is generally done through, there is Hadoop, there is Spark. Okay, mainly it is done through this process. So now how Hadoop and Spark works, they are not in context of this video, but technically they work on the concept of map and reduce. So there is a parent-child concept that for example, there is a system and there are multi-system below that. Okay, so there is a, yes, so there's a master child concept, not parent child, I'm sorry. So this is a master system and there is a slave system. Okay, so master and slave concept is there, and work is allocated in there. So I'm not going too much into that. Now what are these data warehouses? So for example, they can be a data, it can be a normal SQL server, for example, that you see SSMS, okay, SQL Server Management System, or they can be Teradata, for example, and they can be, there are multiple other options are there. Now the problem with this is that traditionally it was good, but as the data size increases, it really gets very difficult to store things on hard disk normally like this. So what we do, that we have cloud services now. Cloud services are like AWS, mainly they are called Azure. So of course AWS by Amazon, Azure is by Microsoft, and there is GCP, that is Google, from Google. Okay, and there is Snowflake as well, and there are lot of things available nowadays. So how they help is that they help you scale your database storage. Either you can put them on cloud and you can use whenever required, right? So again, there's a lot of technique here how it is done. It is done through clustering and all those things. We don't need to go there, but just to understand, right, they can be stored either there or it can be stored there. Then there are NoSQL databases, as I mentioned. So for NoSQL there are Couchbase, okay, there is MongoDB, and there is Cassandra. So these things are there. So these are the various storage device, so storage systems that are present. So all this work from raw, so as I mentioned, from getting the raw data to storing that raw data in a warehouse, it is done by data engineers. Okay, now data engineers are like, there are multiple names for them. Okay, they can be called data engineers, they can be called data architects, they can be big data architects. So there are a lot of names that are given. So I will just move forward with this one. So let's create the whole pipeline once again. So what happens, that this is, for example, now this is where your real data was present. Okay, so this is your OLTP data set. Now what happens, that you apply your system, you collect this raw data set. Okay, so you technically, what you do, you collect this raw data set. Now after collecting them, these you pass this to, so you have to pass this particular data set and store in a data warehouse or a data lake. Okay, data warehouse or data lake. So as I mentioned, all this work are handled by data engineers. So it can be data engineers, you can call them, or you can call them data architect. Okay, you would have heard lot of job roles there. Okay, they can be called big data architect. Okay, big data architect, and big data engineer, big data engineer, big data architect. There are, like, whatever you, wherever you see this engineering or architect term, it means this only, that getting the data from the raw format and storing them there. Now here, from here the story changes. Now here the analysts, scientists, they come. So I will now discuss about how analysts take up from there. Okay, so again, let's say this was my raw data. Okay, now my this raw data was processed and it was saved into a data warehouse. Okay, so this part we understood till now. Now what happens, that this data is not clean. Okay, this data will have discrepancies that you need to handle. Okay, so far we did extract it from a particular source and we loaded it to a particular platform. Now it will have discrepancies like missing values, duplicate columns, or incorrect labels. Like, there are a lot of issues with that. So what you need to do, you need to actually correct this data, and this is called transformation. Okay, so this is called transformation, where you convert your raw data into your so that it can be actually used. And again, after doing transformation, you can either store, there are two methods there. You can either store it on the same server, or you can migrate it to some other place. So if you have seen, there are multiple projects. There are some data migration projects you would have heard about, right? Data warehousing project you would have heard about. So these are those only, that you transform the data. So you extracted the data from here. Okay, you transform the data. Now what you have to do, you have to load it to whatever server, what is your final destination, right, where your analysts are going to use that particular data set. So this is called ETL process, extract, transform, load. There is also a process called as extract, load, and transform. Just like we did here, we extracted from raw, we loaded into a data warehouse, then we again transformed, right? So it depends in which order you want to do. It can be an ETL process, it can be an ELT process. So there is no good and bad. It totally depends on how your company processes things. Okay, so now data is stored in the final, and this is called OLAP, that is online analytical processing. Okay, this is the data that you see in your company. So whatever data you see, like for your dashboards, for your modeling, this is that particular data sets, OLAP. Okay, now again, this process is also done by data engineers. So do you realize that how much significant role data engineers play in getting the right data towards you? And this is the reason that data engineering is a very skillful job. It requires a lot of technical knowledge, it requires a lot of knowledge of tools, and that's why it is one of the highest paying jobs right now in market. Okay, so this becomes OLAP, where you loaded data to various servers. Now we will move ahead. Okay, now I have the data present with me, which I did basic formatting, and now I want to use this. So I have this data with me, which was cleaned, which was transformed, and it was loaded data set. Okay, loaded data set. This data set is mostly tabular data. Okay, and sometimes it is no tabular as well. Now from here, how the process changes is that you do analysis or you do analytics. Okay, so what is analysis versus analytics? In analytics, for example, let's say you have this loaded data present here. You can do two things from here. Okay, you will first of all analyze it, and you will identify past trends. That, okay, for example, let's say I had data from Swiggy. I'll analyze, okay, how many transactions are there, what was the average transaction value, okay, what was the peak hours of any particular order, those kind of things, which restaurant is having the highest rating, those particular things, whatever thing has happened in past, that is called analysis. Okay, so analysis means historical. Okay, and analytics. So analysis is historical, and there comes analytics. Analytics comes using the data to predict future. Okay, predicting future is called analytics, and analyzing historical data is called analysis. So this is the difference between these two. Now what you do here, you do multiple, like you can do Power BI dashboard, or you can do some ad hoc reporting which is required. Okay, you do some basic analysis depending upon whatever you do. So this role is taken by data analysts, right? So most of the work that you do, you lie here, data analyst, or you can say BI analyst, or you can say, let's say, there can be a BI architect. There are a lot of names given to these roles, but all these are same. Analyzing the data, either you can create report or you can create some ad hoc report, ad hoc analysis, whatever thing is done there. So after this process, now comes to the data science. So for example, you have the data set ready, now you want to forecast. So for forecasting, you use various ML machine learning algorithms, and these tasks are done by data scientists. Okay, where you, for example, you do a time series forecasting, you create a clustering model, you do a regression model, all those things are done by data scientists. Okay, now after this comes machine learning engineer. So what machine learning engineers do is that they not only do the science, they actually understand which particular models will do. They scale these particular small data science solutions into big machine learning solutions, right? So data scientist role is not only running the machine learning models. Data scientist roles are primarily doing analysis and making predictions, but doing the machine learning task is done by data engineer. And to get these models in real time, okay, this is called MLOps, machine learning operations. So what you do, whatever machine learning pipeline you have built, you have to ensure that, okay, in real time this particular thing is working. Okay, you wrote a code for machine learning, it is actually working in a real time. Let's say you are doing a fraud detection machine learning model, right? So in real time, whenever a transaction comes, your model should detect the fraud transaction that time itself. So this is achieved by MLOps. A new kind of role that has arrived recently is called AI engineer. It is similar to machine learning engineer, where you deal with traditional machine learning algorithms. Here you deal with artificial intelligence, like you do the Gen AI and the NLP and those kind of stuff. So this is the whole these are the whole roles that are present in the data market as of now. Now let me create a final flowchart once again so that you guys can stay in your mind. So first of all, you have a, let's say this is a raw data. Okay, this is done through OLAP. You take this raw data and you store into data warehouses. Okay, you store into data warehouses or you store into data lakes. From this, the data is transformed, okay, and it is loaded into the final storage, into the final warehouse, wherever you need to store it. Now comes the next part, that from there from this particular like wherever data is stored, you do two things. Okay, you can either go into the analysis part, okay, analyzing the data, or you go into the analytics part. Okay, analytics. So so this whole part was done by data engineers, this part is done by data analysts, and this part is done by data scientists. So what all data analysis do you do? Like they can be like for example, dashboarding and like basic ad hoc, like whatever we discussed. And analytics, you do data science, you do machine learning, you do MLOps, okay, and you do AI engineering. So AI engineering, and here you do, for example, dashboard, you do BI development, you do ad hoc reports, those kind of tasks you do. So where does this course lie? In this course, we will be dealing with these particular roles. So we will not be dealing with the data pipelines, we'll be dealing with this particular part where you have your data set ready, final data set stored. How do you analyze? How do you create dashboard? Like how do you develop major ad hoc reports, or how do you do major analysis, and how do you do predictions? Okay, so this course is about analyzing the things that have happened and making predictions about the future. So that's why this is called EDA, exploratory data analysis. Okay, as we mentioned. So this was the whole pipeline as I just mentioned. you don't need to worry much about. So this particular part, as I mentioned, is of data engineers domain, and this particular is of data analysis, and this is data scientist. So we'll be focusing on this. So I hope you are clear now what all data roles are there. No role is less, no role is like every role is very much important in this whole pipeline. Okay, you cannot say that a data scientist is more important than a data analyst, or a data analyst is more important than a data engineer. To be honest, everything is equally important. It's just that the requirement of tools that you need to know for each level, each category varies, and you really need to decide which part you want to stick and which part you want to pursue. So a good choice of career is to either do a data engineering alone, or do a data analysis plus data scientist type of thing, or you go into ML engineering, or like you take specific fields like ML engineering or ML ops. Totally depends upon your area of interest. So thanks a lot for watching this video. Now we will start our major introduction to course. So just let me walk you through that what all are we going to have in this course. First of all, we will be doing in Python. There are certain Python libraries that we will be addressing. So what are they? They are like NumPy, Pandas, Matplotlib, okay, and there are Seaborn, and there is scikit-learn. There are a lot of libraries. We'll be doing that first of all. After that, we will take a data, we will understand the whole machine learning pipeline. Okay, machine learning pipeline, what all things go inside that. So there is data pre-processing, there is data pre-processing, then there is model selection, then there is like deciding the optimum model. Okay, so these things are there. Now to do these things, we do various, so we'll explore each of the step individually. So majorly we'll cover data pre-processing steps. There are multiple methods there, I'm not discussing them right now, and there is dedicated section for this. And then we will do the model selection part, and then the model evaluation part. And after this, we'll be doing 2 to 3. So one project is on credit risk modeling, where we are credit risk modeling. This is our project 1. Okay, this is, and second is our fraud detection. This is our project 2. Okay, along with this, while doing this project, we will do another project 3, that could be of e-commerce, or it can be of a similar data set. So the project 3 will lie here. And after that, you will be given a project 4 as your capstone for this particular course that you need to submit on time. So this is the whole architecture of the course. Now I have planned this course for over 8 to 9 days. I know you might think that it is very short time, but actually it is not. I mean, you just need to understand what all Python libraries are. You do not need to remember everything, because things will be available for you in your cheat sheet, or you can even ChatGPT as well, right? No one expects you to remember all of the Python functions or everything. That thing your logical testing comes in DSA. Here, no one is going to test how many matplotlib functions do you remember, how many pandas function do you remember. Yeah, basic one you should know, but no one is going to ask that. You should remember the approach, that whenever I get a data, what all steps do I take. Okay, that we will discuss in the next video. So it is going to be very interesting course, because we are going to do some real-time work which happens in company. So even if you have zero knowledge of Python right now, you can move ahead. Just try to understand what all things I'm doing, right? Even if you don't know, I'm repeating this again and again. Even if you don't know Python, I will try to explain the concept as close as possible. I know it will be a little challenging for you initially, but you will understand. And if you know basics of Python, then you're very good for this course. So I'm looking forward for this course. Thanks a lot again for watching this video. You can rewind it if you want to understand all the data roles, or I'll create a separate dedicated video to each section later on. And so that's all. Thanks all, and I'll see you in the next video. And please subscribe to Data Sense YouTube channel, because I see a lot of people have not done that. So please do that for us, and I see you in the next video.